Et salut tout le monde, on se retrouve pour une interview avec Spire Labs. Hey Matthew, how are you doing today?
Doing great. Happy
Great?
to be here.
Yeah, I'm very happy. I'm a big fan of Based Rollups, so I have a lot of questions about this. Can you tell us a bit about you? How did you end up here? Your experience, Web 2, Web 3 maybe?
Yeah, so I'm 17 years old, so I don't have a lot of experience before Spire Labs.
Okay.
My kind of foray into crypto was through NFTs. That's when I kind of first learned about the space. But I didn't find them super interesting. I got enough kind of technical knowledge from that to dive deeper eventually into MEV. And over the past kind of 3 or 4 years, I've been working on a lot of MEV related things and then doing some Ethereum research and then working on Spire starting about a year ago. So kind of a lot of my background is very technical focused and
Mhm.
especially focused on Ethereum and kind of the block building market and some of the things that are like very applicable to base sequencing.
Okay. Yeah, I've seen your presentation in DevCon. You're really like a bit if maxi. You think Ethereum have all the networking. I'm totally agree with that. I like this view. So that's why you choose to scale it in the pure way, right?
For sure. Yeah, I think
Yeah.
there's a lot of you kind of define what you think an extension of Ethereum is. I believe that Based Rollups and kind of Spire's uh, product is one of the purest ways for sure. That doesn't mean like I don't think other ways to scale Ethereum will be successful or will like be net good for crypto. But if you really care about Ethereum, then I think Based Rollups are probably higher on your priority list.
Okay. Can you explain a bit what base rollup is, like in a simple way?
Sure. So all blockchains are sequenced by a sequencer at any instant in time. So on Bitcoin, you don't know who that sequencer is until after they've mined the block, and then after kind of the block has been mined, then you learn that the winning miner was a sequencer. On Solana, there's a leader for 1.6 seconds, and on Ethereum, there is the block proposer for 12 seconds. Now, these are kind of all three of these are given the protocol granted rights to sequence that blockchain, to sequence kind of the next block that will be produced. In some cases, they choose to auction off rights to sequence that block to a more sophisticated entity that we call a builder. So on Ethereum layer 1, the proposers, there are thousands of them, they choose to delegate their responsibilities of proposing a block to a builder through an auction. And so these specialized builders compete to produce the most valuable block and then tip the proposer enough to get their block included in the chain. So if me and you are block builders, we might try to build the best block. I might bid 5 ETH, you might bid 6 ETH, then your block would be included in the chain. Now, that kind of process of auctioneering the sequencing is important because when you auction off the sequence, you also auction off access to contentious state. So this is very useful for things like arbitrage and other kind of financial applications. And these are very time sensitive, right? So both of us are competing to be the first on chain, and we want to be on chain as fast as possible. And so there's a lot of incentives at play here that are that mean that both of us as builders are trying to get access to the most order flow from retail traders that are trying to run the most kind of complex, sophisticated algorithms, et cetera, et cetera. So there's a bunch of efficiency that's built up in these builder markets. Now, based rollups come in as a special type of layer 2. So, I won't define that here, but essentially, these are layer 2s that do not have a centralized sequencer. That's the difference, is this sequencing. They actually use something called based sequencing. And the definition of that is going to be a little bit more complicated, so I'll try to simplify it as much as possible. I view it as kind of two big components. The first is that the sequencer for the layer 2, so remember, every blockchain has kind of one sequencer at any point in time. The sequencer for the layer 2 is the same as the sequencer for the layer 1. So on the layer 1, the sequencer is the proposer who delegates to builders. The same on the layer 2. It's the same proposer delegating to the same builder through kind of the same auction process. And this enables the the winner of that auction, the winning builder, to have the ability to kind of compose between these two domains. They can do shared sequencing. They can, have state communication back and forth, and with some other features, and we'll talk about that later, I'm sure. And then the second kind of component of base sequencing is reorgs and finality with Ethereum layer 1. And so this, a lot of people are struggle to understand this at first, but kind of the key here is that if Ethereum layer 1 undergoes a reorg and the blocks in the chain that were included don't become finalized, then the same thing happens on a base rollup. And so the latest tip of the chain of Ethereum is also the latest tip of the chain of every based rollup. And the reason this is important, we can talk about the technical reasons why this is important, but the kind of fundamental reason it's important is because this means that block proposals for the base rollup and for Ethereum layer 1 are atomic, and you need that atomic property to do cross-chain contract calls that are synchronous, right? So we call this synchronous composability, and that's kind of the dream that we're rooting for. It also allows you to do real-time censorship resistance, and so if the Ethereum layer 1 improved its censorship resistance properties, then these kind of same properties could be communicated to the layer 2 without the waiting for a delay. So every layer 2 delay, layer 2 today has a multiple block delay for force included transactions. On a base rollup, you could remove this requirement because of that atomicity of block proposal property, because you're reworking with layer 1.
I see. And so, all this thing about stage, what stage you will be at launch? Like directly stage 2, or doesn't even make sense for you?
So we build code to give other application developers the ability to launch their own based rollups. So our stack will support stage 2, but it's up to applications if they want to actually go down that route. I will encourage them as much as I can. It's just not something that we can directly influence.
Okay, but by using directly the sequencer of Ethereum, you're decentralized, and you have the liveness, and also it's safe, and you don't have to trust the sequencer to post on the L1. It's obvious, right?
True. Yeah. So every block on a layer 2 doesn't become like canonical, doesn't become like really included until it actually appears on the layer 1 through kind of this checkpointing process.
Okay, and can you summarize quite simply? You talked a bit about it, but just to summarize, what's the incentive for a layer 2 to move to a base rollup?
Sure. So when I gave my definition, I talked a lot about what are kind of the technical properties of what makes a base rollup a base rollup. Why is that important? But now I want to talk about why is a base rollup better than a centralized sequencer rollup on a lot of metrics. So the first one is the network effects of being a layer 2 are kind of greatly expanded. So for a centralized sequencer layer 2, they do not have composability or interop with layer 1 at the speed, at the cadence of a base rollup. This is just a fundamental law. And this has the downside that if you'd like to do composability like trading or arbitrage, or even all sorts of cross-chain interactions between layer 1 and a centralized sequencer layer 2, you're not necessarily able to do that, right? That gets you in it's a very, very difficult thing to do, and it requires a lot of more collateral and token incentives than a base rollup would. And so I think this is the most tangible benefit, is that you can reuse the network effects of Ethereum, which is liquidity. Ethereum has massive amounts of liquidity. Protocols, so behavior, is the most contract code to put in Ethereum. And also, you can also use the tokens that exist on layer 1. So we've spent years building up the Ethereum ETH token. There's also sorts of OG DeFi protocols that have tokens, and being able to access these directly on layer 2 is a pretty massive benefit. So that's kind of the first reason, is you can access network effect of Ethereum. And the second reason just kind of bounces off that, because at least in Spire's case, you have an app chain or a special purpose chain. You can customize that to your kind of your own application needs. So that your execution environment maybe you want to use SVM over EVM. That's an easy customization. Maybe you want to add an EVM precompile. That's something you can do. One use case that we've heard quite a bit is the Ethereum layer 1 is rather slow to add changes to the EVM, right? One of these like account abstraction. And so account abstraction is like really amazing for the user experience. It's really incredible. And we think that the Ethereum layer 1 is, rapidly innovating on this and trying to include something in a kind of future hard forks. But as a layer 2, you could do this today, right? This is not just true about Based Rollups, but because we kind of maintain that decoupling process, we think that this kind of model is better than just doing like a monolithic layer 1 or monolithic layer 2, because you have the ability to customize your execution environment to whatever you want. You could add account abstraction, which is going to be way cheaper than if you did it on layer 1, and you're able to innovate on that so much faster than the layer 1 could because of their kind of unique constraints. And so it's a combination of these two properties, which we call composability and sovereignty, that are kind of, I think they break a lot of trade-offs that have previously existed with kind of protocol deployment options for applications.
I see. And from a user perspective, how would you feel on a Based Rollup? Like, can you use your phone from L1, or it just easier to bridge and cheaper, or is it like you feel you're on the same layer?
Great question. So it's actually up to kind of the front end in the application how they want to shape the user experience. It's very possible that it looks like just another layer 2, which would be a painful experience, I think. But with things like chain abstraction, then it's possible to actually just have it all feel like layer 1. This is something that we're also working on at Spire. Is there's ways to essentially modify how transactions work to make the wallet, kind of trick the wallet into thinking that the transactions are taking place on kind of layer 1 when really they're actually being executed on layer 2. There's a combination of these things that shape the user experience. I'll say there's no bridging step. You're not waiting for a bridge to happen. There might be kind of a deposit step, but that can be linked atomically to another action. So you like deposit and trade instead of bridge and then wait and then trade. If it's like a purpose exchange, then it would just be open a trade, not deposit, and then open a trade, right?
Right.
And so it's these kind of, like, I think the user experience overall gets better, but that is not kind of the primary focus for Based Rollups. I actually believe the developer experience is even more important to look at, because as a developer, like, you're going to give your users much cheaper transactions than you would on like a layer 1, and also have the ability to customize and specialize. And I think that is also extremely powerful. The thing about Based Rollups is that kind of the value prop is so multifaceted, right? They're like a little bit better on user experience, a little bit better on developer experience, a little bit better, when it comes to properties like liveness and security, but they're not like exceptionally better in any single one of them, other than that kind of composability property.
I see. And you talked about DevCon that we could aggregate all transactions from all Based Rollup in the future to make something like atomic and composable. Is that something you could see in the next year, next 2 years, or I don't know, what's your point of view on this?
Yeah, I think so. It depends on kind of the teams working on this, and their ability to ship certain like kind of technical things. So fast ZK proving is something that is really useful in this kind of effort. And a lot of the bottleneck on this innovation is no longer on the base sequencing teams, but rather on the ZK teams who are trying to push for the fastest ZK possible.
So you need ZK in Based Rollup to do this, right?
So there's kind of there's a spectrum of composability. Based Rollups will have better composability than centralized sequencers out of the box, right? You don't need, you can do it with optimistic fraud proofs. But once you add ZK, then you can do kind of two-way communication instantly. And the faster the ZK, the better, right? And so the real benefit here, the real, I guess, improvement is that second thing, is that atomic synchronous composability that is two-way. So I believe that will be the best user experience and the best developer experience that can be offered in the context of Ethereum, but not but based rollups themselves do not necessarily require ZK to get better than centralized sequencer properties.
I see. And I wonder, because you use the sequencer from Ethereum, but they need to be a bit sophisticated because they have to see what the Based Rollup is doing, and maybe they will do ZK in the future. How much percent of the validators can do that, do you think?
Great question. So it's not even the validators that need to do this. So I think what you're referring to is like running a full node for a based rollup. Validators don't need to do this. Only builders need to do this, because they're the ones who are actually sequencing blocks. Now, this kind of abstraction breaks down a little bit when validators want to self-build, and in such a system, there's kind of some more complex interplay between who runs a full node for a based rollup. But I think the easiest way to understand it is that validators will have very, very little additional overhead as the number of based rollups increases. So in Spire's case, we essentially established like a one network request overhead, and that's just to establish like a pre-confirmation delegation. And that, compared to like, interacting with the mempool, which is something that validators do a ton, that's like, a tiny percent of the kind of the bandwidth or execution requirements that validators have. Now on the builder side, it is like a relatively substantial increase in the kind of requirements for that builder. So to be an effective builder, you'll have to run a full node for multiple domains, and that very well might be something that builders kind of delegate. And so you don't need to run it all on like one hot path server. You could put this on servers distributed around the world in the cheapest locations, or just delegate this to an external service provider.
Okay. And talk a bit about counter incentive, because I think it's important. Here, the counter incentive that usually people bring up is you give up your MEV. You're giving up to, of course, Ethereum. So that's a cool way. But for the base rollup, you don't earn MEV. What's your point on this? I think Justin Drake see a future where there is no MEV or very little part. What do you think?
Yeah, great question. So I'll just try to kind of strawman, steelman the other side here, which is that based rollups, because they delegate their sequencing rights to Ethereum, lose the ability to extract MEV from that sequencing. And as you know, MEV can be extremely valuable. It can amount to millions of dollars every year. On Ethereum, it's likely $2 billion or so since the merge. It's a sizable sum of money, right? And so the incentive for some applications or layer twos to switch does become a little bit perverse. I want to spend a few minutes kind of debunking this because it's just wrong. Also kind of elaborating a little bit on why I think even if it was true, it wouldn't be a huge negative effect. So the argument kind of goes like this: because you delegate to Ethereum, you no longer have the ability to run an auction for those sequencing rights for your own layer two. You're no longer the benefactor or the auctioneer in that auction. And so this is true if you always delegate to Ethereum, but based rollups can get the properties that they want without always delegating to Ethereum. You can run we call it a ticketing auction in our case, to conditionally delegate to Ethereum. And so like only some builders can participate in the auction. And so you kind of have a multi-layered auction where the underlying auction is still Ethereum, but you establish an auction on top of that actually limits what the builders can do. The second point I want to make is that MEV over time will likely trend towards zero. So the kind of MEV that is available to be sequenced will diminish over time. So right now it's still a sizable chunk of money, especially on layer twos. But I believe that this will change. And Justin Drake agrees with me on this. Is one of his main points, is that we actually have like all of the research to figure out how to avoid leaking like 99% of MEV. The reason people don't do that is it's just a skill issue, right? Like it's not an easy thing to implement in most cases, but the theory is there, and it's not something that is is going to be a long-term kind of source of revenue. At least I don't believe. Now that's not a super strong argument, because like today it still is. And so we also have to think about, like, in the real world, practically, if we're getting practical, where is MEV actually going? And the answer is not to applications that generate it. It's actually to the sequencers of these layer 2s. So Coinbase, right? Running a sequencer for Base. Or to Ethereum layer 1, to the proposers, right? And so this is where we really have to understand, like, this is kind of a complex incentive game. But today, the generators of MEV, applications and users, are not receiving that MEV. They're not getting any additional value from that. And based rollups, when they capture MEV, allow an application to move from capturing 0% of MEV to greater than 0%, let's say 80%, right? If based rollups can do that. And that gives them the added benefit of having a very straightforward way to increase their protocol revenue, like just more money in the bank, in the treasury. But unfortunately, it also does require some more technical sophistication. And so that's one of the products that we provide, is this kind of like MEV retention service that allows applications to retain the MEV that they generate, which is like the complete opposite of what happens on layer 2s today. And so, yeah, I mean, it's definitely an incentive for layer 2s not to become based, because they like all that money. But it's definitely the kind of an opposite incentive for applications to become based, right? To become based rollups, because we offer them the ability to capture their MEV in kind of a protocol enforced manner, and kind of more specifics manner, I guess, more customizable. Now, the other thing I just want to note is that in the end game, Justin and I both believe that congestion fees will become kind of the main source of revenue for applications, right? They kind of, one of the key services that they sell is the generation of contentious state, and actors will be willing to pay for this. And so whoever can, sell access to that contentious state will be in a position to make a lot of money. That's kind of MEV. But there's also a lot of non-contentious state that maybe users have. They all want to access at the same time. And so as the number of users increases, as the number of bots increases, maybe AI agents, I don't know, there is kind of this congestion problem where lots of users want to use the same kind of application, maybe separate parts of state, but still the same kind of application umbrella. And this is something that is just like a gas fee, and can be easily captured by an application. So there's no moving from a layer 2 to a base rollup, you'll be able to capture that just the same as if you were on a layer 2. And interestingly, today, layer 2s do not give that congestion fees back to applications. So, for example, on Base, kind of the largest generators of congestion was Friendtech, I guess, and then Telegram trading bots, right, on Base. And there's like meme connectivity, so like swaps up there, but that's beside the point. The key thing is that the all of this kind of this congestion is more money for Coinbase. Like Coinbase gets this revenue, whereas if these applications were to move to a base rollup, they'd be able to capture that revenue, extra revenue from congestion, for their users or for their own protocol treasury.
Okay. I had a take. Tell me if I'm wrong, but that's what I said yesterday in my video. I said that today we know L2 like a big ecosystem with multiple dApps, but if we see a future with app chains, I mean, maybe they don't really give a damn about MEV. Maybe they just want the fees on the dApps, or maybe someone like Sonium, which is a layer 2 of Sony. Maybe they just want to have Mindshare and sell their NFT or whatever. So maybe there is I don't think there is so much money. Do you think like base money is so much for them? I think it's like 50K or 100K per day. Maybe less. Do you think I'm wrong here, or it's?
Yeah, I'm not entirely sure.
Yeah.
I guess the question is like, how important will MEV actually be to some of these applications versus things like
Mhm.
Mindshare? Um, and yeah, I'm honestly not sure. It does depend on like a lot of path dependence. I think the most tangible thing I can add is that based rollups or based app chains have
Mhm.
the kind of that mimetic um, part to them, right? So being an app chain has historically increased token valuation.
Mhm.
So application developers that maybe are on a layer two and want to make their investors happy could consider moving to an app chain for that reason, which is not a purely technical one. Being an app chain also like kind of does make you more distinct from your competitors. And so if Aave created an app chain
Mhm.
and Compound did not, then the Aave kind of pitch would be a lot stronger because they have they have a lot of potential for future innovation and have this
Mhm.
kind of isolated environment while still being composable with Ethereum. So yeah, I think this is a really valuable um, kind of benefit to the uh, kind of the app chain vision here is that there's a pretty strong kind of mind share effect for being an app chain or being kind of your own layer two. This is why I think you see things like Unichain existing is
Yeah.
because maybe it's possible to get this on a general purpose layer two, but having your own general purpose layer two means you can put your name behind it. You can promise token holders more value, etc. Right?
Mhm. Yeah. Yeah, and they have the right on the MEV now because they are app chain, so they have the block right. Yeah.
Right, right, right.
Can you talk a bit about your stacks? What is it? What can you do? I thought it was only for app chain, but you talk about rollups, so maybe whole ecosystem. And can you do alt DA? That's a real question. I was thinking.
Yeah, great question. So one of the trade-offs that base rollups make is that they're so closely coupled to Ethereum that the
Mhm.
properties of DA that they use also need to be very closely coupled to Ethereum. Right
Mhm.
now, blobs are the only DA, like Ethereum blobs are the only DA that fit this description. But this is not necessarily to say that alt DA providers won't be able to offer that. So I'm bullish on things like EigenDA that are kind of closely coupled to the Ethereum cadence, that 12-second block time, etc. And I believe that it's possible to have LTA. Like, so there's nothing theoretically stopping it. It's just none of the LTA providers today can offer this service with their kind of current design.
Mhm. Okay. 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 I see. And yeah, let's talk a bit about preconfirmation, because the limit right now with base rollup is that your limit from the 12 second of Ethereum, because that's the sequencer come from there. So I think you have a solution about this, like Spire have a pre-confirmation solution. Can you talk a bit about it? What is it like, and how it goes? When can it be live?
Yeah, great question. So there's a whole bunch of teams working on pre-confirmation protocols.
Mm.
But to have like a fully featured pre-confirmation experience, you need a lot of different pieces to work out. So, uh, there's be helpful to have a diagram up right now, but essentially there are a few different layers. So there's interaction with the user, which is through a pre-confirmation RPC or router. That's something that Spire is building. And then this router interacts with pre-confirmation protocols. And there's a whole bunch of different teams working on this. And then these pre-confirmation protocols interact with like the underlying sequencing layer of Ethereum. So this is interacting with proposers, and people like Commit Boost provide some of those we call them sidecar services. And so this kind of like three-layered approach. There's like vertical integration, here and there, but this is kind of the three distinct like architecture points, right?
Mm.
And the Spire's, like I said, building this router. So we offer an RPC that users can put in their wallets that will kind of out of the box by default, with no changes to their wallets, get them a really clean pre-confirmation experience. And so that is something that um, other kind of pre-confirmation protocols will need to also adopt if they want that really clean user experience out of the box.
Mm.
Now, you asked about timelines a little bit. The various pre-confirmation protocols already have a pre-confirmation live on mainnet. So pre-confirmations are, theoretically ready. There's a whole
Oh.
bunch to do in terms of moving from inclusion pre-confirmations to
Mhm.
execution pre-confirmations. We can talk about the difference there.
Yeah.
But the overall kind of architecture design stays somewhat similar. And so the inclusion pre-confirmations work, green check mark on that. But execution pre-confirmations are still down the line. I would say for certain by the end of next year that we'll have some protocols that are ready to go.
Okay. Yeah. Can you explain? Actually, I don't even know the difference between inclusion and execution. Can you explain quite simply?
Of course. So
Yeah.
there's a few different types of pre-confirmations that you might hear. Layer 1 pre-confirmation or based pre-confirmation. But one type that's interesting is like what is actually being pre-confirmed. So I like to define a pre-confirmation as a promise to what will be added to the tip of the blockchain. So something about a block. And blocks have kind of two important things when it comes to transactions. The first is like what transactions. So we have transaction A, B, and C. And then the second is ordering. So the transactions are A and then B and then C. Now, inclusion pre-confirmations just say that your transaction will be included somewhere in the block. And that's nice, except that you don't know how that transaction will be executed. So if you're making a trade, you might get a different execution price than you wanted. Now, with an execution pre-confirmation, you're getting a promise about the ordering of that block such that you can figure out or just be told what the execution result of your transaction will be. And so for inclusion, my transaction will be included somewhere, whereas with a execution pre-confirmation, my transaction will be included in some ordering so that it results in this execution. So if you're making a trade on Uniswap, then you might see that you're going to get 500 USDC for your 0.1 ETH.
Okay. All right. Yeah. The difference is very important. Yeah, for user experience, I guess.
For sure. Yeah. So, well, one thing I want to highlight here is that the inclusion pre-confirmations work very similar to execution pre-confirmations for non-contentious state. This is things like token approvals, sending token balances, sending ETH balances. Actually, the majority of transactions on Ethereum are interacted with non-contentious state. But contentious state is where you really need execution pre-confirmations because this is places where the state could very well change, right? And so that is something that we really want for things like trading and other kind of DeFi related transactions. But that is not something that is like an absolute requirement to improve the user experience for even the majority of transactions that users make.
Okay, I see. I want to talk a bit about the transaction, the cost of transaction on Based Rollup, because actually Tycho, I think is the only one right now, and is like paying, I think 80-90% of the rent on blobs. So the cost is a lot for them. I think it's users are going to pay a bit of this difference, and plus you add pre-confirmation that you pay. Maybe you have the right to not pay it, or I think it's developer choice. But what do you think? How much could it cost with and without pre-confirmation on a Based Rollup?
Great question. So yeah, so transactions on a Based Rollup could cost the same as on a centralized sequencer. There's no or very, very little overhead that is added here. Now, if you want to interact with Ethereum and do like a swap using Ethereum liquidity, then you do have to pay for at least some of that Ethereum gas costs. So yeah, it would be more expensive if you're interacting with Ethereum, but could be the same as any other layer 2 if you're just doing kind of a sending a token to your friend. Now with pre-confirmations, they don't necessarily change how much transactions cost in in most cases, but they can definitely change like how fast transactions feel to a user. So that is, I think it's another valuable thing. One thing that we notice is that users actually care sometimes more about the speed of their transactions after a certain kind of cost limit. And so kind of the end user, retail user might be like, I'm willing to pay, 1 cent or 5 cents. It doesn't matter to me. That's almost nothing. But they might care if it takes 12 seconds or 12 milliseconds, right? And so it's kind of a trade-off between these two. It's like, how can we improve the user experience practically and give users what they actually want instead of just like guessing that they actually want, they want to move from 1 cent to half a cent transaction fees. It's like I don't think most people actually care too much about that.
No. Yeah, for sure. And then with preconfirmation, you're like just bound with the limit of speed of light, right? Of internet, I mean, because you can do like 20 milliseconds, or I think Rise pretend to do 10 milliseconds.
Yeah, so this is where we get into some more kind of complicated networking things, and I'm sure the Solana guys will get mad at me for anything I say next. But the pre-confirmation kind of minimum latency, and this is true for any blockchain, is the time it takes to go from the user to the to some sequencer back to the user, and so this kind of sequencer could be distributed around the world, and so it doesn't necessarily need to be like one box, like in New York City or something. But the whatever that latency is depends on the user's kind of network, setup, right? If they're running on like a hotspot versus like an Ethernet connection, it also depends on like kind of what location they're in, like what physical location. And so I can't tell you for sure, but I can say kind of the lower bound is the speed of light, kind of the time it takes for light to travel between yourself, the sequencer times 2, because you need to make 2 network hops. I believe in practice it'll be a little bit more, but I'm pretty confident we'll see roughly on the order of 100 milliseconds, which is already like significantly faster than how long it takes for a page to load in when you're using like a web browser.
Okay, definitely. And I talked a bit about Rise chain. I wonder if you have if you're excited about some Based Rollups that are coming, and which one could use Spire, or if you have any name you can drop or not. I don't know.
I won't say any names right now, just in the interest of privacy. But there are some other Based Rollup projects that are using their own kind of base sequencing. Rise is one of them. I'm really excited about Rise. I'm friends with the team. Tycho Gwyneth is another one that they're doing a technical design similar to Spire, but with kind of a different strategy. I'm really bullish on Gwyneth. And then there's a few other kind of Based Rollup teams that are working on their own kind of goals and priorities that I think are also interesting. So that would be Puffer, Nethermind, with their products Surge and Rogue as well.
Yeah, I'm really excited about the Gwyneth. It's like it's really weird, this booster based rollup, but it looks like a really great solution. What's your point of view, and how do you see this?
Yeah, so the technical design of Spire and Gwyneth actually looks rather similar for kind of practical things. They use kind of different terminology that I think is somewhat confusing. But yeah, we're all working towards the goal of offering synchronous composability, which is something that kind of both of our designs are built around doing. So it just so happens that they look similar, which I think is a good thing.
Okay, it's the same because booster-based rollup is like an extension of the state of Ethereum L1. Spire doesn't do this, right? Oh, I'm wrong.
Kind of, yeah. So effectively, we don't call it a base booster rollup, but effectively we do offer that same kind of extension of layer 1 state.
Okay, I didn't know. Okay. I wonder, so what's business model of Spire Labs? Do you think there is a future where you need a token or something, governance? I don't know.
So our kind of official statement on this is that the base stack, our product, does not require a token and would probably be worse with the token. So I'm generally like very philosophically against launching a token unless it actually has some utility, there's some reason to launch it and not just kind of pump and dump. But we are not entirely sure, where a token will fit in our architecture. We have some ideas that have been discussed internally for the past year, but nothing that is ready to be kind of have public eyes on it. I say we will have a token at some point. It's likely that will happen. I won't say 100% chance, but it's likely. But the actual details of that token are completely up in the air right now, and I cannot share any more than that.
Okay, and do you think there is a world where we see a Spire L2?
Yes. So
based. Yeah.
Our product is a stack that is specially designed for application-specific blockchains or app chains, and so it has a lot of features related to this. But app chains are not always the best for every application, and so maybe you just want to like mess around on layer 2. Maybe you're in middle school and you want to just deploy a contract and see how it works. Now, that is not something that is very difficult in practice. You can do that on a testnet. But if you were to try and do that on an app chain, that would be really painful because you need to set up like infra providers. And so that kind of extra cost overhead prices out a lot of applications and a lot of like kind of new developers. And so to give these application developers a home, there's a distinct kind of chance that we launch our own general purpose layer 2 with the base stack, right, with our own code, just to kind of provide a proof point that it works, but also give kind of smaller applications and newer application developers a kind of welcoming home to launch and experiment with their applications.
Okay, great. I wonder, I use a lot of time to learn about ecosystem of Ethereum, but it's like so big. There is so much innovation going on. It's really hard to have an image of the future, like even in 2 years. I wonder, from an objective point of view, I don't mean like from a based rollup developer, but really objective point of view, where do you see Ethereum and his ecosystem in like 2 or 3 years?
Yeah, great question. So I think I'm pretty aligned with Justin on this. I think that we will have based rollups and specifically based app chains be kind of the home of the majority of applications. And these all use something like Aggréger or shared deposits to do ZK proving, fast ZK proving, to do interop or composability between them. So even though they are like technically separate chains, they all feel like one chain to the end user. Justin said something I agree with, which is that meme coin trading on Ethereum will likely be faster and cheaper than on Solana in the next 2 years. I believe that that's also true, right, on layer 2s. And so I think that once we get to like the limit of these things, it starts to be less about user experience and almost more about like bot experience, right? Like users rarely care about the difference between a couple cents and 1 cent, but a bot, some user running a bot or some AI agent might have kind of very different cost profiling, right? And so at that point, it starts to get down to like the nitty gritty of doing arbitrage, of offering like user experience things that other kind of ecosystems cannot. And that's where I become a lot less sure. I do believe that the kind of architectural benefit that what I'm describing has over something like a monolithic layer 1 like Solana is that we enable parallel innovation. And so everyone uses the network effect of Ethereum. Everyone shares that network effect, which is good for everyone. But they also have the ability to innovate in parallel, improve on, we talked about account abstraction, but improve on all sorts of things. So we could have 20 different app chains all trying different things at the same time in parallel. And this gives them the ability to experiment at just a much, much faster speed than something like Solana could, because they can all try different experiments in parallel and just kind of use the best of those across the ecosystem, share their learnings. And depends a lot on incentives, of course. This kind of a idealistic future, but I hope that we'll be able to incorporate the learnings from other parts of the crypto ecosystem back into layer 2s even faster than those layer 1s can offer, right? So I think the one funny thing that might happen is that there is a layer 2 on Ethereum that looks very similar to Solana when it comes to kind of developer experience, but actually just hard forks before Solana every time. So Solana like eventually is at the scale where they have to do like lots of testing and things, but the layer 2 that is just a copy of Solana can iterate and innovate faster than Solana layer 1 because they don't have to deal with kind of the same architecture penalties that Solana has introduced. I think that'd be really interesting.
And how confident are you that the biggest L2 right now, like Base, Optimus, Arbitrum, move to based rollup? I know Justin Drake is like hyper bullish on this, but he's a guy, he's always bullish on things. So from your point of view, objectively?
I'd say there's a greater than 50% chance that large layer 2s move to being based. But I think the reason for that is not because they say, we can give our users a much better experience. It's rather because they say, we would make a lot more money doing this. And so I think the financial incentives need to be there. I think the best way to create those financial incentives is to build based rollups. That's what Spire is doing, and try to attract applications that generate revenue for Base. So, a protocol like Aerodrome, they're on Base today. They make a lot of money for Coinbase, but if they were to move to their own Base app chain, then Coinbase would stop making that money, and I think that would change kind of the incentives there. So eventually, Coinbase would realize that we almost need to move to a Base rollup to give our developers and users the best experience, but also we need to do that because if we don't, then all of our most valuable applications will leave, and we will end up kind of fighting a losing battle. I don't know if that, how likely that is to happen, but that's why we are building like a technically superior solution, and then we're hoping that the financial incentives are also there, and doing our best to kind of craft those.
And he said some big team are already base built. He didn't give a name. Do you have some names, or are you, even if you don't, do you see L2 talking a lot about based already, or maybe in the future?
I won't drop a name. I have some information I definitely can't share, but I think there are a lot of conversations that are happening at these big layer twos. Justin is pushing a lot of this, like he's getting into meetings with some of these exec teams and trying to convince them, trying to pill them, and some of these are going better than others. I think we're making significant progress towards actually moving a large layer two to being based. But yeah, I'm not. Yeah, I can't share any more than that, I guess.
Yeah, no problem. And
Top
at what?
tier.
Yeah, top tier. Okay, top tier. And at what time do you think base rollup will be like complete enough that anyone could move and be really excited to move? Because right now with pre-confirmation just is not finished. So you said execution is not finished. So yeah, what in the timeline, like when base rollup will be a finished product and completely awesome for everyone?
Good question. So I mentioned ZK proving as being like
Yeah.
one key thing there. I think if I had to give a conservative estimate, I'd say we'll have real-time ZK proving in sometime in kind of late 2025. And so if that ends up playing out, then we'd have to wait quite a while. I think there's also a chance that teams work faster than we're expecting and are able to launch something even sooner. But we'll see. We're not entirely sure on kind of all the info side. On Spire's half, like we have internal testnet live. We'll be launching a version of the base stack in early 2025, and that'll be better than centralized signature rollups for sure. And I think that will offer our application developers just a really high quality experience, and then also kind of support a very easy migration to that kind of synchronous composability, ZK proving endgame that we believe in. So we're not expecting a huge rush of applications on our kind of first launch, but rather we want to kind of innovate and iterate on our stack to move towards that end game that I was describing a few minutes ago with all these layer twos.
Okay, awesome. And yeah, before closing the interview, I just have two questions. First, do you have something we didn't talk about you want to come with?
No, I think that's all the things I wanted to mention. I do have a quick call to action. If anyone's listening to this and they are an application developer, maybe you're young, still in high school or college, and you'd like to get involved with building your own base rollup or deploying on a base rollup and kind of messing around with some of these features, then please reach out to me. My handle is mteamisloading on Twitter, and kind of the official Spire contact point is spire.dev, which is our website, or spire_labs, which is our ad on Twitter. So if you want to reach out, then please do. I think we do a good job of checking DMs. I check all my DMs for sure. And so, yeah, you'll get a response. Yeah. And same goes for any established application developers. If you're listening to this, just stay updated with the news. Then this is kind of the opportunity you were waiting for. We can offer you a really high quality app chain, the best you can get. And I think that would be great for your application. So just reach out, and maybe there's a 10% chance it works out, but I think that's definitely worth the time.
Okay, that's great, and that's a perfect transition to my next question. Is usually I ask every time to the people I host, what would they say to someone like a young investor or just a young guy that want to be part of the crypto world? I know you're quite young, but you make your place in the ecosystem. So maybe you have some advice for someone who want to be part of it.
Yeah, I think we need a lot more based rollup educational content. So if you're interested in doing content creation, then you just need to be able to write or make videos or just do things like that, do drawings. Then please reach out to me. Okay, we'd love to fund that that kind of content creation. I can offer you a job if you're passionate and intelligent. Just reach out. There's we have so many opportunities at Spire, and we also have kind of the ability to really empower a lot of you guys. So if you're curious, and please do reach out. I hope we'll have links in the podcast description. But I think that will be there's almost no downside, right? Just please contact.
Awesome. Well, it was amazing. I learned a lot of things. Yeah, and maybe another time when everything is ready, we can make another one if you want to. And I hope that was enough for you.
That was amazing.
Amazing.
Thank you for the time.
Yeah, no problem, Matthew. Thanks, man.
Bye.